Troy draws a regular hexagon and then draws a smaller hexagon whose corners are the midpoints of the sides of the first hexagon, as shown below. So what fraction of the area inside the larger hexagon is also inside the smaller hexagon? Now, one thing that I noticed is that because this outside hexagon is a regular hexagon, it means that the smaller blue hexagon I've drawn here should also be a regular hexagon, which means that all of its sides and all of its angles are the same. So it's like a square. A square is a four-sided regular polygon, and a regular hexagon is sort of like a square, but a hexagon. And one of the things that I've noticed is that there are some really weird numbers as the answers. We have some square roots in here. Doesn't seem very nice. And one of the ways that I would have solved this is to use Pythagorean theorem. But today I want to show you a much nicer way to solve this. And this is going to be a useful strategy for similar problems when you're comparing areas of shapes. So one thing that I like about the regular hexagon is that when you have a regular hexagon, you're able to cut it up into smaller equilateral triangles, just like this. And you'll notice that with this hexagon in particular, I can cut it up into 6 smaller equilateral triangles. But I can even cut them into smaller triangles. So for example, if I have midpoints like this, then what I can do is I can cut them up even smaller. And because you have a picture in your problem, you can draw this on the picture. So I'm going to do that right here with this with this hexagon. So on this hexagon, I'm going to first cut up this larger hexagon, and I'll try to make the lines a bit straighter. But so what we have is then we've taken all of these midpoints and we've connected them. And I'm just trying to draw smaller equilateral triangles. And one thing you'll notice is that all of these triangles, these smaller triangles, have the same area. So if I count up the number of triangles that are in this hexagon, that will be representing its area. So if you count this up, you'll see that there are 24 smaller equilateral triangles within this bigger hexagon. And that's going to be the area of the large hexagon. So now I need to find the fraction of this area that is also part of the blue hexagon. So now I need to count how many equilateral triangles are in the blue hexagon. And so you'll notice that we have a full triangle in here, right here. So all of these triangles that I've marked are contained inside the blue hexagon. So that's going to be part of its area. And you'll notice that there are 12 of these that I've marked. But I also have these triangles on the edge here. So what do I do with these triangles? So you'll notice that, I should use a different color here. So you'll notice that with this triangle, it's formed by two halves. I have this half, which is this half right here, and I also have this half. And you'll notice that both of these halves are half of an equilateral triangle. See, inside this triangle, this part is 1/2 of that. So what that means is then this red part that I've shaded, the area of that equals one smaller equilateral triangle. So you'll notice now that I have 6 of these longer triangles, and each of these triangles has the same area as one smaller equilateral triangle. So if I add in the area here with the area of my other triangles, then that will be the area of the whole blue hexagon. And so there's 6 red triangles and 12 of these blue equilateral triangles. So that is in total 18. And that is my area of the small hexagon. So now if you want to find the fraction of the area within the larger hexagon of the smaller hexagon, you're going to take the smaller hexagon's area divided by the larger hexagon's area. So if you simplify 18 divided by 24, which is 3 times 6 divided by 4 times 6, then these cancel out and you're left with 3 over 4. So the answer we can see is C.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.